Welcome, my dear students, to the class of 11th English Medium. The subject is Statistics, Chapter 8, Function, brought to you by Vitan Sir. Previously, in my last tutorial, we discussed about domain, codomain, and range of a function, and we took two illustrations based on that. We calculated domain, codomain, and range of each and every function. You can find the tutorial at the top right corner of your screen. Let's start with the next topic, that is types of a function. So functions are basically not always similar. There are many types. Among many types, there are three main types of a function. The first one is one function, many-one function, and constant function. I am going to explain all these three types one by one to you. Starting with one function. Now, as you can see here, the word one itself denotes something that they are connected one by one to each other. If we take f as a function from set A to B, then for any two different elements of set A, if its images or functional values are different, then it is called one function. What I mean to say here is that for each and every element of A, if we get a different values of images or answers, then we can say that for each value of A we get a unique answer. We can call that one function. Let's take set A B here. A is A B C D. Okay, now what I am doing here, the function, the relationship I am trying to depict here is the rank of the alphabet A B C D. So what are the rank of its alphabets? A is 1, B is 2, C is 3, D is 4. So they are directly connected with each other. So each of these alphabets are connected with one and only one numbers. So we can say that this is a one function. So one of the domain are connected with one of the codomain. Okay. Starting with the next one, many-one function. So if we compare the words here, the f is a function from set A to B, then for any two different elements of set A, if its images or functional values are same, then it is called many-one function. So we can take randomly any two values of domain A, and if we find that okay, the answer for both of them are same, then we can say that it is a many-one function. Let's check an example for that. A is 10, 2, 15, 4. If you remember, this is the same example which I gave in my very first tutorial, and the answers here are more or less. So the function here is more than 9 and less than 9. So 10 is more, 2 is less, 15 is more, 4 is less. So as you can see here, that some of the answers here are similar. For example, the functional value of 10 and 15 is similar, that is more. Functional value of 2 and 4 is similar, which is less. So when we get similar type of answers like this, we call it many-one function. What I mean to say here is that many of the values are related with one answer. So many, that is 2 and 4, are related with just less. 10 and 15 is related with just more. So that's it, many-one function. And according to our syllabus, the last type, constant function. If f is a function from set A to B, then for each and every elements of set A, if its images or functional values are only one and same, then it is called constant function. So what I mean to say here, that if images, all of the images or all of the functional values are same, then we call it a constant function. Let's take an example once again. If you remember, I also gave this example in my very first tutorial, where PQRS are the subordinates of X. So if our relationship here is superior subordinate, then if we take a P, we get the same superior. For Q, we get the same. R and S, for all of these four subordinates, we get the same superior. So each of the values of the domain have the same functional value, that is x. So we call it constant function. Let's take some illustrations, examples to understand this better. We will start with illustration 4. We have to state the type of a function where f is a function from set n to set n. And now we know that fx is x square. We know that domain, that is the first value here, is natural number. Codomain, the second value here, is also a natural number. We know that natural number n ranges from 1, 2, 3 up to infinity. And when we put these values into x square, 1 square 1, 2 square 4, 3 square 9, etc. values we will get. So this is the domain, these are the images. As you can see, for each and every value of x, we will get a different value as an image. So when we have that, we can say that any two values of the domain, the images are always different. Therefore, this is a 1-1 function, that each value of domain is connected with a different value of codomain. Okay, moving on. Illustration 5, we have to state the type of function for f is a function from z to n and 0. That is, n union 0 means natural numbers start from 1. But we also need a 0 in there. So this time our codomain is from 0, 1, 2, 3 up to infinity. And we are taking z, which is whole number, positive, negative, doesn't matter. So domain is from dot 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 -3, -2, -1, 0, 1, 2, 3 dot dot dot, starting from negative infinity, ending at positive infinity. Codomain here is n union 0, so it starts from 0 and then we take the natural numbers 1, 2, 3, 4 dot dot dot. What we know here is that our fx is x square. So we have to start from this infinity and we are putting these values into our equation of x square. You know that -3 square is 9 and +3 square is also 9. -2 square is 4, +2 square is also 4. So that means we are getting similar values. For -3 and +3, we are getting the same answer, 9. So let's check it out from infinity, positive, negative. If we take these values and put them into the equation, we get 4, 1, 0, 1, 4. We are getting same answers. We are getting repeat answers here. So for any two values we take, the images are same. Okay. For -3 and 3, the images are same. -2 and 2, images are 4. For -1 and 1, images are 1 and 1. So we can call it a many-one function. So two values have same answers. Okay. So that becomes a many-one function. When each value has different answers, it becomes 1-1 function. Well, 2 or 3 values have the same answer, it becomes many-one function. And illustration 6, in that the first one, type of a function, f is a function from z to r, fx is 100. As you can see here, this is just 100. Okay, no x is there. That simply means domain is, as we have known, from negative infinity to positive infinity, r is just a real number. So any real number, positive, negative, decimals, whole, doesn't matter. And then we may take any value of domain, any value we take and put here, it will become 0. In each and every time we will get the same answer, that is 100. Okay, so that means that no matter what we put, we get the same answer, 100. Naturally, all the images for these elements is a single value, 100, and that is what we call a constant function. So because each and every element of domain has only one answer, 100, this is a constant function. The last illustration, the last question for this, state the type of function between dates of a month and days of a week. Dates of a month is a domain, days of a week is a codomain. Now as you can see here, you take any dates of a month, 1, 2, 3, 4, 5, 6 up to 28 or 29 or 30 or 31. Okay, and then put them in front of weeks, days of a week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. As you can see here, for example, if you start with one date as a Sunday, okay, then that means the 8th date will again be a Sunday, 15th date will again be a Sunday, the 22nd date will again be a Sunday, and 29th will also be a Sunday. That means 4 of your dates are same, getting the same answer as a day, that is Sunday. Similarly, if you are doing that in your notebook, if you take a second date, it will be a Monday. 9th will also be a Monday. 16 will be a Monday. 23 will be a Monday, and 30 will also be a Monday. That means that your dates, many of your dates are getting a same answer. When this happens, we just need to remember that the domain dates of month have similar images as repeated days of the weeks, and therefore we can say that this is a many one function. Okay, that many of your dates have one answer. If all of your dates have one answer, it's a constant function. And if all of your dates have different days, not a single day is repeated, then that becomes a one-one function. I hope you guys have understood properly this concept of types of functions, that is one-one function, many-one function, and constant function. I will prepare a video of the final exercise of this chapter in which I will try to explain some of the questions based on types of functions or domain, codomain, and range, and the upcoming titles. Next time what I am going to discuss is equal functions and real functions. Okay, these are the two types of functions, and these are the last topics of this chapter. Basically, this is a very small chapter. So in the next tutorial, I will complete the concepts of this chapter. Maybe I will create an extra tutorial for solving the exercise questions if I feel like it, and if I have enough time, and if I have enough demand from you guys. So if you guys want to get the solutions of the final exercise for this chapter for extra exercise, extra practice, let me know in the comment section below. So if I feel that okay, you guys really want it, and then if I get a time, I will also prepare a video for the final exercise of this chapter. Thank you very much for watching this. Give me a thumbs up, subscribe if you are a new person, and let me know how you feel. Thanks. See you next time. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.